Okay, we're going to look at some of the calculator activity problems that I have. I posted a sample calculator activity sheet with the explanation of how to do it, but here I'm just going to do this on video. Like the first problem, we're going to use the graph of the function f of x is equal to x to the third minus 3x minus 2 to find f of 3.4. Okay, so here I'm going to use the calculator to do this type of problem here. Now I'm going to enter f of x is equal to x to the third minus 3x minus 2 by pressing the y equal button, which is at the very top, and you should get the y equals menu. If you have any equations in your y's, you want to go ahead and press the clear key to clear those out. If any of your plots are on, what you want to do here is press your up arrow button and then press enter on your calculator to unhighlight those plots. Then press your down arrow key to go back to y1. In this case here, we'll enter our equation x to the third. So for x to the third, I press the xt theta for the x, and then press the caret key for my exponent, and then the exponent of 3, then minus 3, and then x plus 2. And then from here, I'll go ahead and press, to be on the safe side, I'll press zoom, and then I'm going to select number 6, which is the standard window. What that'll do is it'll give me a window from negative 10 to positive 10 on the x-axis and a negative 10 to positive 10 on the y-axis. And that's what the graph of x cubed minus 3x minus 2 looks like. Now I want to find f of 3.4. Here's what I'm going to do. I'm going to go ahead and press second, which is the yellow key, on the 83. The blue key is the second key is the blue key on your 84. So press second and then trace, which is going to give you the calculate menu. And from that you want to select number 1, which is the value, because we're trying to find the value of that function at x is equal to 3.4. So once you press number 1 for value, you should get x equals with a blinking cursor, and then you'll type in 3.4 and then hit enter. And in this case, we're going to round to 2 decimal places. So here, x is 3.4 and the y is 31.10. So here, to answer that particular question, f of 3.4 equals 31.10. Okay. So that's how you'll find the value of that particular function at x is equal to 3.4. Okay. In this case here, number 2, we're given an equation f of x is equal to x to the third minus 5x minus 1. Now here we're going to find 3 x-intercepts. Here we know we got 3 x-intercepts because the highest exponent for f of x is 3. Okay, so let's go to our calculator. We're going to go to y equal, and we're going to clear out this equation that we have in our calculator, and then type in x to the third using your x for xt, x for your x, well, xt theta for x, and then your caret key for your exponent, and then 3. And by the way, the caret key is the key that's below the clear key, by the way, as you can see. And then minus 5, and then x for your xt theta, minus 1. So your screen should look like this. And then next press, to be on the safe side, press zoom, and then select number 6 for the standard window. And that's your graph of that particular equation. Okay, now here we're going to find 3 x-intercepts. Here, this graph is crossing the x-axis at 3 different places. What we want to do here is find each x-intercept, starting with the one on the left, in the middle, and on the right. Let's start with the one on the far left-hand side. Okay, so here we're going to press the second key and then trace to get the calculate menu. Now we're finding the zeros. Anytime we're finding the x-intercept, we're finding the zeros of that particular function. So here we're going to select number 2 for 0. And you should get this menu. Well, this message that says left bound. We're finding the one on the left-hand side. So what we want to do here is position this cursor, and somewhere you should see a blinking cursor on your screen. What you want to do is position that blinking cursor somewhere below the first x-intercept. So we're going to use our left arrow key to position the cursor below the first x-intercept. Once you've done that, press enter. And then you should get a message that says right bound. Okay, now we want to position the blinking cursor above the first x-intercept. So we'll go use our right arrow key to put the cursor above the first x-intercept. And then hit enter. And then after guess, you go ahead and press enter. And that's one of your zeros. Rounded to 2 decimal places, it will be negative 2.13. And your y is going to be 0. So that's one of our x-intercepts. Negative 2.13 and 0. Now let's go back to the calculator to find the second x-intercept, which is the one in the middle. I'm going to have to position the cursor above and below this time. So here we're going to press second and trace. And again, we're selecting 0 because we're finding the x-intercept. Now this time, the blinking cursor will be positioned above that second x-intercept, like this. And then you're going to press enter. And then you're going to position the blinking cursor below it after right bound. And then press enter. Then after guess, you'll press enter. And that's the second x-intercept, which is negative 2.0 and 0. So your second x-intercept is negative 0.20 and 0. Okay, now we're going to find the third and final x-intercept, which is on the right side. Now the cursor has to be below and above this time, because we're doing this from left to right. So here we press second and trace, and then select number 2. And then for left bound, we position the cursor below it using the right arrow key. And then press enter. You'll get a message that says right bound. And then you're going to position the cursor above it. And then press enter. Once you're done with that, go ahead and press enter again. And you'll get, now I just have to read this off to you if you can't see it, positive 2.33 and 0. So in this case here, it's positive 2.33 and 0. So those are my 3 x-intercepts for this particular graph of that function f of x equals x to the third minus 5x minus 1. Alright, the third one, you're going to find 2 x-intercepts. You're going to graph this function f of x equals 2x squared minus 28x plus 17. But you're going to change the window to 0, 20 for the x coordinate. Now I'm going to show you how to do that using the calculator. Alright, let's first press the y equal, and then clear this equation out, and we're going to enter that new equation. 2x squared, press the number 2, xt theta for your x. Now for x squared, there is an x squared button on your calculator. That x squared only gives you the exponent for 2. and then minus 28x, 28, and then press the xt theta for your x, plus 17. Oops, 17. That's your equation. All right, now the next step, we want to change our window for the x-coordinate. So we're going to press the window key, which is on the very top of your calculator or next to the screen. Notice my x-min is -10 and the x-max is 10. All right, let's change that from 0 to 20. X-min, we change that to 0. Hit your down arrow key to go to x-max, change that to 20. And for the x-scale, we can leave that as is. And the y-min and the y-max and the y-scale, that can stay as it is. Now let's go ahead and press the graph button. Okay, and that's what part of the graph looks like, but that's okay. Because the only thing I want are my x-intercepts to find out where this graph is crossing the x-axis. So let's do second and then trace. Now we're finding the x-intercept again, so we're going to use the 0, which is number 2. And then for left bound, we're going to use our left arrow key to position the cursor somewhere above it. And you have to keep pressing the left arrow key until you can see the blinking cursor. And forgive me, it's taking a while. There we go. Okay, there it is. Now we press enter. And then for right bound, we use our right arrow key to put the cursor below it. And then hit enter. Then after guess, press enter. And you're going to get, let's see, 0.64. Which is what I come up with, 0.64. And 0. Okay, that's my first x-intercept. And that 0.64, that's rounded to 2 decimal places. Okay, now let's go back to our calculator and get the other x-intercept, which is in this case on the right side. So here, second, and trace, and then select number 2 for your 0. And then you're going to use your right arrow key to position the cursor below that second x-intercept. It's got to be below, like what I have here. And then press enter. And then position the cursor above it. And then press enter. And then after guess, we just go ahead and press enter. Okay, don't worry about the 1e to the -11. That's a number that's close to 0. So we'll let that slide, because that'll be your 0 on the x-axis. So here, 13.36 is what we want. And 0. So those are my 2 x-intercepts for this particular graph. So here you have to change your window for your x-coordinate. Okay, number 4. Here we're going to find the y-intercept of this equation. F of x is equal to 2 times the quantity x plus 3 squared minus 9. Okay, so here we go to y equal. Clear out this equation. We're going to enter that equation as we see it on paper. So in this case here, we got 2, and then left parentheses, x plus 3, press the x plus 3 in parentheses, and then use your x squared key for the exponent of 2, minus 9. Okay, now here I'm going to press the zoom and then number 6 to go back to the standard window. That's my equation. Now what I want to find is the y-intercept. In other words, I want to find out what's my y value is going to be when x is equal to 0, because if you recall, your y-intercept is the point where the graph crosses the y-axis. So in this case here, let's do second and then trace, and I'm going to press number 1 for the value. And since the y-intercept, we want to find out what's the value of that y-intercept when x is equal to 0. So I just type in 0 in this case for x, and then press enter. And there's my y-intercept right there, which is in this case a 9. So the y-intercept will be the ordered pair 0, 9. Alright, number 5. Here we want to graph this function, g of x is equal to the quantity 1.6x plus 3.5 squared minus 5.5. Now the window for the y-coordinate, we're going to change that to 0, 20. And then we're going to find the y-intercept. Okay, so let's go to y equal. And we're going to type in our new equation. So let's clear this equation. And then 1.6 here, left parentheses, 1.6. Then your xt theta for your x plus 3.5, close parentheses. Then hit your x squared button for the exponent of 2. Then minus 5.5. Okay, that's your equation. Now let's change the window. Okay, let's go to window, press the window key. In this case, we're changing the y-coordinate. So here our y-min, if you hit your down arrow key to go down to y-min, you'll change that to 0. Your y-max, hit your down arrow key, change that to 20. The y-scale, we can leave that as 1. The x-min and the x-max and the x-scale can stay the same. Now, let's press the button that says graph. Okay? That's part of that graph. However, that's all we need because we only want to find the y-intercept. Now, just like we did in the last problem, the y-intercept is the point that crosses the y-axis when x is equal to 0. So let's press second, trace, and then we're going to select number 1 for the value. And for our x value, we're going to enter 0 because the y-intercept is always the ordered pair 0 and whatever that y-coordinate is. So we're finding what the y-coordinate is when x is equal to 0. That will give us our y-intercept. So once you enter 0, press enter. And you'll get 6.75. So that means that this graph is crossing the y-axis at 6.75. So the ordered pair here will be 0, 6.75. Alright, number 6. We're going to find one relative maximum and two relative minima. We're going to graph the function h of t is equal to t to the 4th minus 6t squared plus 6. Okay? Let's go to our calculator and press y equal and clear this equation out. Now, let's enter t to the 4th. Well, the t is like an x. So let's just say x. Okay? Now, if you want to, you can change this to h of x equals x to the 4th minus 6x squared plus 6. So for this intent and purpose, let's change that, let's say x, and then the caret key for your exponent, which is below the clear key, and then 4, x to the 4th, minus 6, xt theta for your x, and then x squared for the exponent of 2, plus 6. Okay? Now this time I'm going to press the zoom button and then select number 6 for our standard window. And that's what the graph of that function looks like. This looks like a W. Now we want to find the relative maximum and the relative minimum. There is only one relative maximum, and that's the highest point here. There are two relative minimum. That's those 2 points down here at the bottom. Let's find the relative maximum first. Okay, so let's press second and trace to get the calculate menu. Now we're going to calculate the maximum. That's number 4. And as you can see here, the left bound. In this case here, we want to position the cursor somewhere on the left-hand side of the highest point on this graph. So let's do that and then press enter. For right bound, we want to position the cursor on the right-hand side of the highest point of that graph. And then press enter. Then after guess, press enter. And you should get this relative maximum. And in this case, that's a very small number here. But I'm going to say that relative maximum is like 0 and then 6, rounded to 2 decimal places. So here the maximum I'll say 0.6. Because at 1.4523 e to the negative 6, that's this number. But the 2 decimal places will end up being 0. Okay, now we need the relative minimum. And there are 2 of them. And we want to find out what they are. Alright, let's find out the one that's on the left-hand side, the one on the left. Okay, so let's press second and trace. And this time we're going to select number 3 for minimum. Now the left bound, we want to use our left arrow key to position the cursor on the left-hand side of the lowest point of the graph, like I have here, and press enter. Then for right bound, you want to position the cursor on the right-hand side of the lowest point of that graph, and press enter. And then after guess, press enter. And we'll write our answers to 2 decimal places. That x value will be negative 1.73, and the y is negative 3. Okay. That's one of our minimum points. The other one, we're going to do the same thing. In this case here, let's press second and trace, and then we'll select minimum again, which is number 3. Now, our blinking cursor needs to be placed on the left-hand side of the lowest point of that graph. That's on the right, or close to it. Then press enter. Then the right bound, the blinking cursor needs to be on the right-hand side of the lowest point of that graph, like I have here, and then press enter. Then after guess, press enter. And this one is a positive 1.732, and y is negative 3. Okay, notice that you have to write both the x and the y coordinates for your maximum and your minimum point. Okay, so that's number 6. Number 7, we're going to graph the function f of t is equal to t squared minus 20t plus 37. We have some restrictions here. We need to change the window to 0.50 for the x coordinate and to negative 150, 0 for the y coordinate. And then you're going to find the coordinates of the relative minimum. Okay, so let's go to our calculator and go to y equal. Let's clear this equation now. Now t squared, we're going to treat that as x. So here this will be x, and then hit your x squared button for the exponent of 2, minus 20x plus 37. Okay, so again, you can write this as f of x if you like, is equal to x squared minus 20x plus 37. Okay, now we need to change our window. So let's press the window key. Our x-min will have to be 0. 0. X-max is 50, because our window has to be, for the x-coordinate, 0 to 50. And I'm going to change this x-scale to 10, because it's from 0 to 50. And that x-scale means that each mark on the graph will have to be, represents 1. So from 0 to 50, there's going to be like 50 marks on the x-coordinate. So to have fewer tick marks, let's make the x-scale 10. And then the y minimum from 150 to 0, we'll change that to negative 150. Now keep in mind the negative key is down at the bottom. That's your negative key. And then your y max is going to be 0, so hit your down arrow key, go to, and type in 0. Let's also change that y scale to 10. Okay. And then we'll press graph. Now we want to find the coordinates of the relative minimum. That's the lowest point on this graph. This is only part of it. I only need that part to find the lowest point of that graph. So let's press second and then trace. And then minimum is what we want, because that's the relative minimum. So we select number 3. And then left bound is where we want to position the cursor on the left-hand side of this graph. There we go. The left-hand side of the lowest point of that graph. And then press enter. The right bound, we're going to position the cursor on the right-hand side of the lowest point of that graph. And then press enter. Then after yes, go ahead and press enter. That's your relative minimum. We're going to say 10.00, negative 63. That's our ordered pair. Okay, so that represents the ordered pair for that particular graph, or the relative minimum for that particular graph of that function. All right, number 8. Here we're going to graph the function p of x is equal to negative x squared minus 34x minus 30. Now here you want to change the window for both the x-coordinate and the y-coordinate in order to get a relative maximum on the screen. And then you're going to find the coordinates of that relative maximum. Okay, so back to the calculator, go to y equal. Let's clear this equation out. We got negative x squared. The negative key is at the very bottom of the calculator, so make sure you press the negative key and not the minus key. Use the negative key for negative x squared. So for negative, and then xt theta for the x, and then hit your x squared button for the exponent of 2. And then minus 34, then hit your x t theta for your x minus 30. Okay. Now, if I try to press zoom 6, I'm not going to get the entire graph. However, I do need to change that window a bit. So let's go to window. And then we're going to try to have to play around with this a bit, because I didn't give you any type of window for both the x and the y coordinate here. So let's see. Let's change this from 0 to 50 with 10. And then the y max 0 to 50 with 10. And let's see what happens. Okay. Well, there's no luck there, so let's play around from negative 50. Okay. Okay, if I try negative 100, okay, that won't work. Let's keep it at negative 50, but I need to change the y's to 100. Okay, if I increase it to 200, okay, that's a little bit better. Let's try 250. Go back to window. Okay, let's try 300 to get the whole thing. Okay. Oops. That needs to be, the Y max needs to be 300. Now I'll change the Y scale to 50. Okay. This is not working out. Negative 50 to 50. Then graph. There we go. Okay. So here's what the window, let me go back to the window key so you can see what I'm doing here. Negative 50 to 50. X min is negative 50. X max is 50. And the X scale is 10. The Y min, I'll let that be 0. The Y max is 300. And the Y scale is 50. Okay, so here, when I did the graph, it looks like this. Now, that's part of it because I only want the relative maximum, by the way. So here's what I'm going to do here. Press second, and then trace. And then for maximum, press number 4. And then here, your left bound, you want to position the cursor on the left-hand side of the graph, of the highest point of that graph, like I have here, and then press enter. And then the right bound on the right-hand side of the graph, the cursor needs to be placed on the right-hand side of the highest point of that graph, and then press enter. Then after guess, go ahead and press enter. That maximum is negative 17 and positive 259. So you have to write down your x and your y coordinate. Negative 17 and 259. Okay? Alright, so that's what the maximum looks like. And my regret is that I didn't put the what order pairs, what window that would work. So if you press the window key, I'm telling you what that is. From negative 50 to 50 for your X min. X max, well, X min is negative 50. X max is 50 with an X scale of 10. Then your Y max is 300. Your Y min is 0 with an X scale of 50. Okay. And here I had to play around with that in order to get the find out so I can view that maximum point. Right, number 9. If I can get to it. Here we go, number 9. Find the coordinates of the points where the graph of the functions p of x is equal to 3x plus 2 and q of x is equal to 2x squared plus 5x minus 3 intersect. So here we got two graphs. We're going to find out at what 2 points do those graphs intersect. Okay, let's go to y equal. Now let's go ahead and clear this equation out, pressing the clear key. The first equation was 3x plus 2. So we type in 3 and then xt theta for the x and then plus 2. We'll type that in y1. Hit your down arrow key to go to y2. We're going to type in the second equation, which is our q of x. That's 2x squared, 2 xt theta, and then x squared for your exponent of 2, plus 5 x minus 3. Those are my two equations that I will be using. Now here in this case, I'm going to press zoom and then the number 6 to go back to the standard window. Those are my two equations, the line and the parabola, or the graph of the curve. Now, that line and that parabola intersect at two different places. So I want to find out where do these lines intersect. So here I want the ordered pairs. Let's do the one that's at the very bottom here. Okay, so let's press second and then trace. Now we're finding the intersection of the two, so we want to select number 5 for intersect. You should get first curve. What you want to do is position that blinking cursor somewhere close to the intersection of that first point, which is right here. You want to position the cursor somewhere close to it, and then hit enter. And then after second curve, you can just go ahead and press enter. And then after guess, press enter. That's your first x-intercept. To two decimal places, it'll be negative 2.16 and negative 4.47. Okay, so that's the first x-intercept right there. Now let's find the second x-intercept. Second intercept. Well, the second point of intersection is way up here. So again, press second and then trace. And then select number 5 for your intersect. Now you should get the message that says first curve. The blinking cursor needs to be close to that point of intersection. Just put it close to it as possible. And then press enter. Then after second curve, you can just go ahead and press enter. After guess, press enter. That's your other point of intersection. 1.16 and 5.47. You have to write down your x and your y coordinate. 1.16 and 5.47. So those are my two points of intersections of those two graphs. And finally, number 10. Use the graph to solve x squared minus 5x plus 1 equals x minus 2. And here's what I'm going to do. y1 will be the equation or the expression on the left-hand side, x squared minus 5x plus 1. y2 will be the expression on the right side, x minus 2. So in the calculator, go to y equal. Let's clear these two equations. Hit the clear button for the first one, and then hit your down arrow key to clear the second, and then go back up to y1 using your up arrow key. Now here we're going to enter the equation x squared, so here x, and then your x squared button for your exponent of 2, minus 5x plus 1. That's your y1. Then hit your down arrow key to y2, and then type in x minus 2. And then you're going to press zoom and then 6. What zoom 6 is, zoom is at the top. You'll select number 6 for the standard window. That's your line and the curve. We're going to find the intersection of those two, just like we did in number 9. So here's second and trace. Select number 5. And then for the first curve, position the cursor close to that first point of intersection. We're going to use the one that's on the bottom next to the origin. Once you position that cursor close to it, press enter. After second curve, press enter. After guess, press enter. And your first point of intersection is at the ordered pair 0.55 and negative 1.45. See, 0.55 and negative 1.45. 0.45. Okay, now we're going to find the other point of intersection, which is right up here. So here we're going to press second and then trace. Then number 5. Then use your right arrow key to position the cursor close to that second point of intersection, just close to it. And then press enter. After second curve, press enter. After yes, press enter. And that's your other order pair, 5.45 and 3.45. Okay, so those are my 2 points of intersection. Now I think they want the x value, so here they just want x is equal to just that x coordinate of 0.55, and then your other x will be 5.45. Okay, they just want the x coordinate, so here that will be it. So here you just be solving the equation for x, and that means that these two would be your x values. Okay, that should be enough to assist you with some of the problems that are on the actual calculator activity number 2. And if you have any questions, do feel free to come by my office or send me an email, or you're more than welcome to talk with me after class and I can assist you with some of those.